Shri Gurubhyo Namaha children. Today in this session we are going to discuss what are the different operators that we have in Python. The operations being carried out on data are represented as operations. The symbol that trigger the operation or the data, which we call it as operators. Operations are represented by operators as the objects are represented as operands. So, because the operator, which is nothing but it is the thing which performs the action on the data, right? So, we have different types of operators: arithmetic, relational, identity, logical, bitwise, and membership operators. Here, all these operators should be categorized based on two things. One is your unary operator, the other one is binary operator. In a particular expression, if I have only one operand and one operator in the sense which we call it as unary operators. If in the same expression or an action to be performed, if I have two operands and one operator, which we call it as binary operator. So now we are going to discuss what is unary operator. The operators that act on one operand, right? So only one operand and you will be having an operator, such as referred to as unary operator. So here we have two things. One is your unary plus, the other one is unary minus. Suppose if a equal to 5, so plus a means the value will be written. If a is a 0 value, again it returns a 0 value. If a is plus 4 in the sense, no change in the value, it returns the same value. Suppose if it is minus, the value is being modified with the negative value, right? So a equal to 5 minus of a, which means minus of 5. The unary minus gets added with the value. If a is 0, nothing gets changed. If a equal to minus 4 in the sense, minus of minus 4, which is nothing but plus 4 value. Next comes with the binary operators. So we have addition, subtraction, multiplication, division, modulus, floor division, and exponent. These are the binary operators in Python. Now let us see how these binary operators work. Suppose if I am adding the value 4 plus 20, right, which gives us 24. So which is the value? Data item. 4 is a data item and 20 is also data item, which is an operator plus. So here we have two operators, one operator which comes under binary operator, or the value can be assigned with a variable. And b equal to 55. So a plus b. Right, so that's returning 60. Right, the same way addition, subtraction can also be done. If a minus b, we have a value a into b multiplication. Right. So next comes with the division operator, which is slash. Suppose if I am dividing the value 4 by 2. Now you can notice that whatever value that I divide, always your division operator will return a float value. For example, 100 divided by 10 gives 10.0. Same way, 7 divided by 2.5 also returns with a float value. If 13.5 divided by 1.5, in such case also it returns with a float value. Now we'll see with the Next operator, which is called as float division. This float division will always truncate the, or it returns the only whole part of the result. Right. So let us check with the values. 100 modulus, that is not modulus, float division, sorry, float division of 32 returns with the value of 3. Suppose if the same value is I'm working with division operator. See the difference between these two, where float division truncates here, that is, it is not truncating, actually only whole part is being returned, right? Whereas in the case of your float, that is normal division, it returns with the float value. Suppose if it is 7, float division of 3 returns the whole part. Suppose if it is going to be a float value that you are going to do for float division, in such case only the value will be returned as float value. Right? Now in this case it is returning as 3.0. Next comes to the modulus operator. Modulus operator always gives the remainder of that value. Right? Suppose if I divide 6 by 3, sorry, 6 modulus 3, it returns 0. Why? Because the remainder is 0. Suppose if it is 14 modulus 3, right? So the remainder will be, that is 3 or 4 are 12, the balance is 12. That is, it returns the remainder of the expression. Suppose if I divide 7.2 modulus 3, right? So the remainder will be 1.0. It returns, if it is a decimal division or decimal float division, in the sense it returns with the float value. Same way, 6 divided by, that is 6 modulus 2.5, because I'm dividing with a float value, right? In such case also it returns with the float value. The next comes with your under your binary, that is under your arithmetic operator. The next is your exponent operator, which means that the power, right? 4 exponent, 2 stars we have to give. If I'm giving in a single star in the sense, it is multiplication operator. If it is 2 stars in the sense, it is an exponent operator. That is 4 raised to the power 2, right? So it is returning 16. These are some of the operators which we have in Python. That is, these are the arithmetic operators that we have. The next is augmented assignment operator. This operator combines the impact of an arithmetic operator with an assignment operator. Here you can see, here I have an assignment operator which is equal to, and I have an arithmetic operator which is plus. So both these operators are being combined and written as x plus equal to y, right? So an x variable where we are storing it, that is an x variable. So you can write it in a short form as x plus equal to y. The same way, x equal to x minus y can be written as x minus equal to y. So in this case, you can write all the operators. That is, an augmented operator can be written when you are writing in an expression, right? Let us see a small example based on this. X equal to 4. X equal to, I have to initialize y equal to 6, right? X equal to x plus y, right? So print of x. So what value is being written? Okay. Now let us see a small example based on the implemented operator. Now I'm going to assign a value for x as 4 and y as 7. Right? So x equal to x plus y. Right? So I have 7, that is 4 plus 7 has been given to x. Print of x. So what value is being returned? It is 11. Suppose if I'm writing the same statement as with an augmented assignment operator. So how will I write? X plus equal to 1. Right? So what is the value present now? Print of x. So what value is written? 18, which means that now what is my current value of x, which is 11. 11 plus 7, which is 18, right? So the same way, even I can write the expression in this format, or I can write the expression in the augmented notation also. Now we are going to discuss relational operators. Python provides 6 relational operators for comparing the values. If the comparison is true, the relational operator results into a Boolean value, which we call it as true, and if it is a false, it returns as a false value. These are the 6 relational operators: greater than, less than, greater than or equal to, less than or equal to, and not equal to. In relational operators, it has some principles that follow when the values are being compared. For numeric type, the values are compared after removing trailing zeros, that is after decimal point from the floating point number. When the strings are being compared, it is based on the lexicographical ordering. So what is lexicographical ordering? Which means how the characters are being internally represented. That is implemented via the corresponding codes that we call it as an ordinal value, or it may be a ASCII coding system or Unicode system. Based on that only, the string values are being compared. To check the ordinal value of a character, you can use the function ORD of character. Two lists and two tuples are equal if they have same elements in the same order. Boolean true, which is equivalent to 1. Boolean false, which is equal to 0 for the comparison purpose. If we are working with the relational operator with an arithmetic operator, relational operator have lower precedence than the arithmetic operator. So here is an expression: a plus 5 greater than c minus 2. So how would it be compared? In the sense, as we know that arithmetic operators has higher precedence when compared with your relational operator. So it evaluates a plus 5 first, then c minus 2, then greater than symbol will be applied, right? But not in this case, because always your arithmetic operators has a higher precedence. Now we'll see some examples based on relational operators. Let us assume a equal to 3 and b as 30, right? So a less than b. So what is the value? Which is nothing but the value will be returned like a Boolean value. The comparison always returns a Boolean value. A greater than b, false, right? So always the comparison will return a Boolean value. Let us see c equal to 3. C equal to a, true. C not equal to a, false, right? So as both are equal, it is returning true value. Here we are checking that if they are not equal, right? That's why it is returning false value. But in this case, C not equal to B, right? Now in this case, it returns with a true value because 3 and 30 are not equal. Now we'll check with the string values, how the comparison is being done. Say, right? If E equal to some N, right? And G equal to, F equal to some character as G, right? Now we are going to compare E and F. E greater than F, true. E less than F, false. So to know how the values are being compared in the sense, we have a inbuilt function called as ORT, right? So print ORT, ordinal value of the variable E, that is, which is nothing but N is a string, that is character. Its corresponding value which has specified in the ASCII coding system, that value will be returned by the ordinal function. The same way, print ORT of F, right? So here it is, the comparison is not based on the string, the comparison is based on the ordinal value. So what is ordinal value of E? Which is 110. 110 is less than 103, right? So in this case, so it is a false statement. 110 is greater than 103, it is a true statement, right? So when we are checking with a string, right, it is not the string that we are comparing, it is based on the ordinal value, right? Suppose if I have a string, another string like this, G equal to GOD, H equal to GOD, right? So if it is this case, so how the comparison is being done? G greater than H, false. So what is the value of G, right? We have to check, that is capital G. The same way, capital value of small g also we have to check. If both are equal in the sense, it proceeds with the next character. The same way, it checks with all the characters in each given string, right? So here, let us check with the ordinal value of capital G, right? It is 71. The same way, ordinal value of small g, it is 103. So G is greater than H, that is 71 is greater than 103? No, right? So by character only the comparison takes place, right? So let us go with the another value, I equal to, God house, right? So what happens if I check that G greater than I, what will happen? False. That is here G O D, next is H, right? So H has its own ordinal value, right? Definitely G is not greater than, because we have here we have only 3 characters, here we have many characters, right? In some cases also it returns with a false value. Suppose if I have a J as, I'm going to give space G O D, right? So now I'm going to compare this G and this J, right? So G greater than J returns true. Why? Because, right? So when the values are being compared in the sense, even I have some ordinal value, that is for space also we have the referencing character, that is non-graphic characters will have some values in the ASCII coding system, right? So for space we have 32, here for G we have a different value, that is G value is 71, right? So 71 greater than 32, obviously it is true. Now we are going to compare based on the list value. Let us assign a list as 1, 2, 3. Right? Let us assign another list n equal to 2, 4, 6. Right? Now I am going to compare the value L equal to M. It is returning the false value. Why? Because if I have two lists or two tuples that is being compared, if I have same elements with the same order only, it is going to return a true value. Right? Now I'm going to change the M value as 1, 2, 3. Right? So L equal to M. Now it returns a true value. Same way it applies for the tuples also. L equal to, I'm going to create a tuple 1, 2, 3. M equal to 1, 2, 3. L equal to M. Now it is returning a true value because it has same number of elements and the same order also the elements is. Right? Now we can compare with the other value also. Now print of A. Yeah. Now I have a value for the A variable. A equal to true. Whether A value is true or not, I can compare with the Boolean also, right? So A value is not true, right? So now you can notice that A equal to true, it is returning a false value. Why? Because always in your Boolean value, which is equivalent to, that is true is equivalent to 1 and false is equivalent to 0, right? So what is the value of A? Here it is 3, whereas the Boolean equivalent value of true is 1. So 3 is equal to 1? No, it is a false value. Same way here in this case also, it is equivalent to 1, it is not equivalent to the true. Here it is expressed in the string format, right? Now we can check the Boolean of A, which is equivalent to true value. Suppose true means which is equivalent to 1. Suppose if I am checking what 0 equal to false, right? So it is returning true because 0 and false both are referencing with the value of 0. Same way 1 equal to true. Here in this case also it is returning a true value because your Boolean values are equivalent to 1 if it is true, equivalent to 0 if it is a false value. Next is your identity operators. There are two identity operators in Python. One is is, the other one is not. The identity operator checks both the operands reference the same object memory. That is, it is not the value. It refers the object where it has stored. Right? So the identity operator compares the memory locations of two objects, returns true and false accordingly. Right? So A is B, returns true if both operands are pointing to the same object. Right? So that is if it is referencing to the same location. Otherwise, it returns a false value. Is not, that is, we have to take opposite of it. It returns a true if they are not pointing to the same object. That is, if they are pointing to different objects, both referencing to a different memory location. Otherwise, it is going to return a false value. Now we'll understand this. Now I'm going to declare A as 10 and B equal to 10. A is B. That is, already we have seen that Python objects are being referenced through the variables, right? That is, already you will be having internally the object will be there. Only we are making the variable to point to that particular object, right? So A is B, true. Why? Because let us check with the ID of A and same way ID of B, right? So you can see that both have the same memory location. That is, A and B are the variables pointing to the same object as 10. Right? That's why if operator, this identity operator is returning a true value. B equal to 12. I'm changing the value of B. Right? So now A is B. No. Right? It is a false. Now A is not B. Now it returns a true value. Now let us check with the ID of B. Right? So what is ID of A? This one. What is ID of B? This one. That is, now B object, that is B variable is pointing to a different object. Right? Is not. Yes, it is not same. Both IDs are not same. That's why it is returning a true value. If both are same only, it returns a true in each operator. If they are different, only it returns a true in is not operator. Thank you, children. To receive our online lessons, please press the subscribe button and you will receive the latest update.